Alright, sorry I'm out today. My daughter is sick, so I'm going to be just recording this video for you to go through some of these sample problems that we have in our notes. So this is the note sheet that says some pretty sound advice, do your homework at the top. There are 5 sample problems. The first sample problem actually has 2 parts, so that's how we get 5 there. We will be using the equations that we looked at are on Friday of last week. So the first one, if you get out that note sheet, you'll see right kind of in the top third of the page the speed of sound that's based on the temperature of the air, and so we'll be using that equation. And if you look toward the bottom of that sound note sheet, you'll see that the sound intensity is the power per area. And that area is because sound travels in all directions, that area we're talking about is the surface area of a sphere. So if you look at the very bottom of the page, you'll see that I is equal to P, the power, divided by 4 pi r squared, where 4 pi r squared is the area of a circle, or of a sphere, I'm sorry. It's the area of a sphere because, again, sound travels in 3 dimensions away from the source. And then if you had 2 intensities and you set those equations equal to each other and you look at them, or look at the powers are equal, it shows how the relationship of intensity varies with the square of the distance away. So we'll be using that, the very last one, the I1 R1 squared equal I2 R2 squared equation. And then finally, on the second page of the notes from Friday, you can see that the intensity level is equal to 10 log of the intensity divided by the threshold of hearing, which is the I sub 0. We'll be using that as well. So those are the equations we'll be looking at today for our problems. So let's just kind of get to it. The first problem says that we have a 1.2 times 10 to the negative 4th watt of power that's passing through 2 surface areas. So we have area 1 and area 2. And it gives us those. It wants to determine the sound intensity at each area. So again, sound intensity is I, we're given power, and we're given area. So pretty straightforward. On the first one, we just take the power, which is right here, 1.2 times 10 to the negative 4th, and divide by the area of the first one, and we get this value for our intensity. Again, plug and chug. The second one we can do in a couple different ways. The first one is we could look at how do the areas compare, and you can see that this is 3 times the area. So if we have 3 times the area, what's that going to do to the intensity? Well, it's going to be 1/3 the intensity, and that's what should show up in this case. You'll notice that these 2 numbers, this is 1/3 of this intensity here. But again, if you don't want to do that, if you just want to take the power and divide it by the area, you'll get that value here. So a couple ways you can solve for it. You can either think about it conceptually, or you can just plug the numbers in and get an answer. I want you to determine the distance from the source. So again, here is where we're looking at, it's a sphere, so this area is referring to is of a sphere. So again, you can take this, we're going to solve for R1. And then we can do the same thing over here, where we could just say the area is equal to 4 pi r squared and plug it in, solve for the radius or the distance from the source, and get the same value, the 0.56 meters. So either way you want to solve, I'd probably solve it this second way, to be quite honest, because it gives you an area. Solve for the radius, pretty straightforward. And if you do that for the second one, we can see that it's further away because it's less intense, so that should make sense that it's further away. So that's sample problem number 1. Again, pause it if you need to write some stuff down for that. We're going to move on to number 2. This one we have a fireworks display. The sound blast reaches listener 2, who's 640 meters away. With an intensity of that, determine the intensity of sound that reaches a person that's 160 meters from the blast. Again, a couple ways that you can do this. One is you can just use math, or you can think about it conceptually. and look and see how do these two numbers relate and go from there. We'll start the first way, which I would just look and say, okay, this is 4 times closer, and so how much more intense will the sound be? Well, it's 4 squared, so that would be 16 times more intense. So if this is the intensity of the listener 2, then listener 1 is going to be 16 times that, which is pretty straightforward. If you're going to do it mathematically, you can use this equation here, and you can plug in and solve for the listener 1. So it's going to be I2R2 squared divided by R1 squared, and we're given all those values. So you plug them in, make sure you square your distances here, and you get the same answer. Again, as long as you say this right here, you put this sentence into your work, then it's okay just to solve and show this right here. Number 3, what's the intensity level of a sound wave whose intensity is this? So now we're looking for intensity level, which is measured in decibels. So we have to use the equation on the back of the note sheet. And again, if you remember, the threshold of hearing is 1 times 10 to the negative 12 watts per meter squared. So we'll be using that for I sub 0. That's a constant right there. So we divide. We then hit our log button, and then we multiply by 10. And we talked about the other day that only the ones digit into the right is significant. So if we look here, we have 2 significant digits. This has 3 significant digits, so our answer has 2 significant digits, which is the ones digit and to the right. So that's where this comes from here, why this is 123.0. Here we go. So in this case, we want to work backward. So it gives us an intensity level of 73 decibels, and we want to know what the intensity is. So we're looking for the I value here. Again, this has 2 significant digits, the ones and to the right. So our answer should have 2 significant digits in the end. The first thing I need to do is divide by 10. And then how do I get rid of the log right here? Well, if I look at my calculator, calculators are set up so inverse functions are usually on the same key, just like the second button and then that. And if you look, it's 10 to the x will actually get rid of the log. So if I take 10 to the intensity level divided by 10, so this would then be my exponent, it will cancel out what the log is here. And that, you can see, is what has happened here. This is 10 to the intensity level divided by 10. It canceled the log, and I multiplied by the threshold of hearing, the I sub 0. That's where I get this equation right here. At this point, I just substitute and solve. So 10 to the 73 over 10 reduces down to 10 to the 7.3. And then when I multiply that out, I get this value here. And again, you can do that in one step in your calculator. Use your 10 to the x key in order to do that 10 to the 7.3. So hopefully you can figure that in your calculator and should be able to, oh, I think I was missing a step right here. There we go. It was in the wrong sequence on my PowerPoint. Apologize about that. But there it is. So if we take 10 to this side and 10 to this side, it cancels the log, and then multiply both sides by I sub 0 to get to here. Hopefully that's pretty straightforward. If you have questions on your calculator, I am going to show you that here in just a second. So I'll show you in a couple different calculators how to get that to work out. Anyway, if you get it, move on. You can do the homework. The homework there is the 1 through 14. So you've got the rest of the period to get that done. We'll go over it, and Friday's homework tomorrow. So I'll see you then. Okay, here's my calculator that I have. I'll put another one out here as well so you can see it. These are probably pretty typical Texas Instruments calculators that you have. If I look here, I have the log button, and then right above it you see the 10 to the x key. Same thing here, I have the log button, and then the second of that, which is the blue, is the 10 to the x there. So I'm going to show you how to do this on your calculator. I'm going to use this one just because it's probably more like the ones that you all have with the display. So in this case, all I have to do is I can hit my 10 to the x key and type in 7.3. So there's 10 to the 7.3, and I'm going to multiply by 1, and then you could put 0.00, but not required. And then e, which on this calculator is, boy, there it is. So my EE button is right there, so 1e to the negative 12. So I have to make sure I hit my negative sign, or actually it's this button down here. It's not my minus, it's the negative 12. And when I hit enter, I get this number right here. And again, to 2 digits, you can see that that 1.995 becomes a 2.0 on that. And again, if I wanted to, I can convert this right to scientific notation. I can hit second SCI, go to SCI, and there you can see it's 2.0 times 10 to the negative 5th would be my intensity. So hopefully that helps you with those to solve those particular problems that you have. The one before it, I think it was 2 watts per meter squared, and if I divide by 1 e to the negative 12, I get this value. I take the log of that, and again I can hit my answer key, so mine is A and S. So if I take the log of that value, I get this, and then multiply by 10, I get this number. And again, I'll take it out of scientific notation here for us so you can see that that came out to be 123.0 for my decibels. And again, so those are ways to solve those problems with your calculator. Again, I hope that provides a little insight for you if you're struggling getting those answers from those sample problems. All right, have a great day.